We'll go over some control-related topics right now, which will be a bit more advanced, but a bit shorter as well. So we'll go over CPDLC. Some of you might know how this works, but I included it because we want to try and include this with as much controls as possible. So basically CPDLC is a tool used to communicate via data link, so data link clearance. This is very handy to decrease voice overload, so frequency time, and readback errors. However, word of note on VetSim, this is via the Hoppy system. This is not official, and this is still rather slow. I tested it and it's about, I know in real life it's about 15 seconds to receive. However, on VetSim it can be up to 30 seconds per message. Basically how it works, you can create a TopSky CPDLC Hoppy code.txt. This is optional if you don't want to punch in your Hoppy code all the time when you want to log in. You can just create this file, put in your Hoppy code. If you don't know what that is, a Hoppy code, just go to just search Hoppy CPDLC in Google, and then you will find a link to a very old looking site, but you can request a login there. That's basically the only thing you need. Everything else is handled via TopSky. So you open the CPDLC window, it's in the top bar, and then the setup. You also have the login window for the custom settings as well. But if you click on CPDLC settings, you open this window basically. So you first connect to the network, then you click on this one, and the login will automatically be filled in, depending on your position, if you have a correct call sign. For example, if you're logged in as Brussels West, this will show as Echo Bravo Whiskey. And then the logon code is either filled in automatically if you use this file, or you have to put it in manually. For me, pre-departure clearance or data link clearance is disabled, but you can enable this. Basically, CPDLC is en route. In real life, currently, this is only used with Maastricht radars above flight level 245. However, they want to lower that, and for us on VetSim, I find it useful. You can choose this for yourself, by the way. They have a minimum level of 9 or 5, so everything en route can receive CPDLC with us. Data link clearance, pre-departure clearance, that's the same as, well, that's what the name says. It's a pre-departure clearance. It's basically a data link clearance. In real life, I think only Brussels has this in our airspace. However, on VetSim you can simulate this for every airport. But that's something that's covered in the Brussels Aerodrome and the plugin guide, so we'll not go over that one. So if everything is correctly filled in, you click connect, and then it will show up in green. A quick side note, it's a very good idea to, when you log in, to put in your info lines the CPDLC logon code, because pilots cannot see this. They have to see it in your info, or they have to look at the Hoppy network, but that's a bit far-fetched. So if you click, for example, in your login, in your info field, you can put CPDLC and then your code, and then pilots will know where to look for. So you just click connect. Then in the CPDLC current window, message window, you can open this either via the top bar, or if you have it in your local settings, you can open this automatically. If a pilot wants to log on, you will hear a beep, and you will see a blue request logon message. Very important note, a pilot should log on via voice first, always. First contact should always be made via voice. When a pilot calls you on frequency, he needs to establish connection via voice, and only then you can continue on CPDLC. And then they can request logon. Basically what you do then, you can click on it, and then you can accept the logon or reject it. For example, sometimes pilots will connect to you when they're not in your airspace or way outside, because they just see it as an active one and they want to test it or something. You can just reject it. If you accept it, it will send a message to the pilot saying logon accepted, and then you're the current control unit. See how you read this? You have the time in Zulu, the call sign. If it's an uplink or a downlink message, which means arrow down is a request to you as the controller, and up arrow is a message sent to the pilot. If everything is, like if it's not blue anymore, so that means that it's accepted by both parties, you can just delete these messages, double click or one click and then remove. But best to keep the current messages window clean. If an aircraft is connected with CPDLC, you will see brackets around its call sign. This is just an indication for you that he's on CPDLC. When they connect, they will flash. When they're connected, when you accepted the logon, they will be like this, just fixed. So how do you use CPDLC in the tag? You just give an instruction in the label as you would normally. So you would click on it. For example, this one is an altitude clearance. You click on it, you give them a descent, then they will turn blue. Blue means that it's an uplink. You will see it in the current messages again. You give the instruction to descend to flight level 210. If you double click it right now, you actually cancel the message. So you need to keep it like this until the pilot accepts it. As soon as the pilot accepts it, it will turn gray like the previous one, and then the instruction right here will also turn the standard white. Something different, if you want to do it direct, Usually if you want to put in a direct to for an aircraft, you just do it the normal way in the label. However, with Top Sky, you need to do it via the heading menu. So you have to click on the label on the heading menu and then point. And then it will open the flight path. And then you need to click on the waypoint that you want and direct to. And that's how you issue a direct via CPDLC. There's another one kind of instruction you can give, and that's free text. So basically, if you open the call sign menu, go to more, and then CPDLC free text, it will open a window with a lot of options. Some very interesting ones. An interesting one to use is the radar service terminated one, which is not used in real life that much, but on VATSIM obviously it is. So this is basically the handover to Unicom. You can click this, it will send the message to the pilot. As soon as they reply it, you can release a tag to end the CPDLC, as you would normally. Some other interesting ones, you can ask them to contact you over voice. If they send a free text, for example, pilots can send you a free text asking if they want to leave the cockpit. You can send an approved report back. Reroutes, Eric put some good ones in, for the standard ones to London, Gatwick, all that kind of stuff. And then some typical descents, so descents via the LOA. So this is basically how a standard one looks. However, this one is a bit wrong. I'll show you why in a bit. So I gave him a descent, flight level 210. He sent a reply. So that one is now done. I send him a free text to frequency change approved. However, before he replied, I already terminated the CPDLC. This was a bit too fast on my end. And then he sent a reply to that one after I already logged off. So this is a good example to show what happens then. So you will get a pop-up on your Euroscope which says reply received after log off or something. Basically what this means is that you already sent a different message, or basically cancelled this one, but he still sent a reply. This one is gray instead of white, which means that it's cancelled, so to say. So you can just easily discard this as well. So as soon as you release the label, it will automatically log off from CPDLC, and you'll see it will send to the pilot service terminated and then log off. You can again delete these by double clicking it. Alright, then we'll go over the trajectory. Trajectory is basically everything that has to do with the vertical, lateral, and the time-based path of an aircraft. Why is this important? It's very important for sector sequence. Sector sequence is basically all the sectors that an aircraft would pass, which is programmed in Euroscope. For example, an aircraft coming from Frankfurt going to London, and Brussels is on East and Western line. The trajectory would be line radar, Brussels East, Brussels West, London. And that is how the automatic sector sequence would be in Euroscope. This is also very important for altitude restrictions, because the descents that you see in the tag, the LOA descents, the climb restrictions, all that kind of stuff, they are based on trajectory. Some things to keep in mind when thinking of trajectory. Sometimes on VATSIM, and I think even in real life, pilots will file step climbs. For example, initially they'll climb to I don't know what, and then they suddenly have to be on a lower airway, which is restricted to 180. If they use SimBrief or something, it will automatically put in the step climb, but pilots will not look at it, and they'll just keep flying. This is very irritating for controllers, because if they come into your airspace, you will sometimes see that their sector exit level is super low, which is not according to LOAs and all that stuff. And then you need to have a look in the route and remove all the unused step climbs. This will just keep your, make your trajectory not correct. If you give headings, this will also interferes with the sector sequence. For example, with London, if they have all the sectors online, it's really based on the trajectory. If you give vectors for example, an aircraft that routes via Coxie, but they need to go via the north, which we see a lot. If you put them on vectors and not a direct, you will not have the correct sector in your label to transfer to. So you need to put them on a direct or manually select that sector for it to be correct. So headings don't account for the sector sequence. Something else, so this is basically the label. As you can see, this is the sector exit level, sector exit waypoint. However, if an aircraft is already transferred to you, for example, Brussels East transferred the aircraft to us early, well, not too early, but it's still in his volume. If the aircraft is not in your volume yet, this will not be correct. So right now in the tag it says that we can climb into 360. However, because he's departing from Liège, he can only climb to 240. Now we can only see this if the aircraft passes our sector boundary. So right now he passed it, and then you can see that the climb restriction is 240. This is why we still enforce everybody to learn the LOAs, know the restrictions, because these things, you just need to know them. So keep an eye on this. Make sure to know that if an aircraft is not yet in your volume, the exit coordination will not be correct. An interesting trick that Eric showed us. You can actually skip yourself in the sector sequence. For example, Brussels East is very busy. You see this aircraft, He's climbing to 180 and you want him to go directly to Brussels upper. By the way, this video shows all the sectors, so we'll jump a bit. If you click on it, if the aircraft is still with the other controller, you can actually change it to a different one. When now Brussels East sees a different frequency on this one, it will show orange because it's changed. And then Brussels East will not have to do anything. It will automatically, if you click on transfer, it will automatically go to the sector that Brussels West selected. So if you click transfer now, it will automatically go to Brussels Upper, which is right here. This can be very handy to ease workload. Some other interesting ones are the distance tools, including Top Sky. So if you click Alt-P, you get a trajectory-based distance tool. Click Alt-S, and it's a heading distance tool. So you have the two examples right here. The orange ones are the trajectory, the blue ones are the headings. So basically this will show the flight path, but you can use this to easily spot conflicts and all that stuff. And to delete these, just right click on the end of the line. So this is the point where the two tracks will be the closest together of each other. If there's a conflict, you can easily spot it right on this line. Now we'll go over some advanced separation. This is taken from the manual that Matthias sent me. So basically, for horizontal separation, you can use en route vectoring. Some theory about that, which I found very useful, which some of you might know. Basically, 1 nautical mile of separation is gained for each degree turned after 60 miles. So that's a very good rule of thumb. Some examples. 60 miles to the conflict point, you need 5 degrees for 5 miles. Well, if you have a conflict occurring in 10 nautical miles, you give one aircraft 30 degrees, and then they will be separated. In general, rule is to give vectors 3 to 5 minutes before the conflict occurs to avoid errors, because as soon as you put aircraft on a heading, that will mess up your trajectory, and you might create conflicts that you didn't see before. Some tips: give both aircraft a heading, which will slice the degrees in half. For example, if you have a conflict in 10 nautical miles, give both aircraft a heading 15 degrees, and that will result in a total difference of 30 degrees. And plan ahead. Something we also teach on control, I hope, is basically as soon as an aircraft enters your airspace, you scan the whole sector, starting with the beginning and the end point, and then the en route for possible conflicts. You scan if they have to descend, have to climb. You plan ahead, because that's the main thing in controlling a control position is planning ahead, having a general overview and seeing problems very, very early on. On approach, you can fix a problem very quickly. You can just vector them around. However, on control, that's not really useful, because every vector is a delay for a pilot, and that's not what we want. You want them to be as sufficient as possible, and because on control you have aircraft coming from everywhere on all altitudes, flight levels, sorry. You have to really watch out for conflicts and all that stuff. Alright, that's the end of the presentation. I want to thank Eric, Matisse, Simon, and Matthias for helping me with the theory and setting this up. I hope you all find it useful. If you have any questions about it, feel free to ask them now.